Hello guys, hope you're doing well. I'm Said and welcome back. In this video, we're gonna talk about the index shifting rule. Sometimes we wanna rewrite a summation by changing its index. This is called shifting the index of summation. The most important idea is this. If we change the index, we must also change the limits and the expression correctly. For example, suppose we have the sum of ai from a equals 1 to n. So let k equals I plus 1. Then I equals k minus 1. Now we must change the limits. When I equals 1, so k equals 1 plus 1 is 2. And when I equals n, so k equals n plus 1. So the sum of ai from I equals 1 to n equals the sum of when I equals 1, so k equals 2, so k equals 2, and when I equals n, k equals n plus 1, n plus 1, ai equals k minus 1, k minus 1. This is the basic idea of index shifting. For example, rewrite the summation using an index that starts at k equals 0. When I equals 1, so I minus 1 equals 0. And we want the new index to start at 0, means k equals 0. So k equals I minus 1. So let k equals I minus 1. So I equals k plus 1. Now change the limits. When I equals 1, so I minus 1 equals k. So k equals 0. And when I equals 5, I equals 5. So k equals 5 minus 1 is 4, right? So the final answer is the sum of I squared from I equals 1 to 5 equals the sum of I is k plus 1. K plus 1 whole squared from I equals 1, so k equals 0. From k equals 0 and I equals 5, so k equals 4. So from k equals 0 to 4. Notice that the value of the sum does not change. We only change the way we write it. Number 2, rewrite the summation so that the index starts at j equals 1. The sum of 2i plus 1 from I equals 3 to 8. So when I equals 3, so I minus 3 equals 0. And we want the new index to start at j equals 1. So j equals 1. So if we add 1 to both sides of the equation, we get I minus 3 plus 1 equals 1. So I minus 2 equals 1, and we want the new index to start at j equals 1. So I minus 2 equals j, right? So let j equals I minus 2 or I equals j plus 2. So we have the sum of when I equals 3, so I minus 2 is j. So 3 minus 2 is 1. So j equals 1. And when I equals 8, so j equals 8 minus 2 is 6. 6. And I equals j plus 2. So 2 times j plus 2 plus 1 plus 1. So we have the sum of 2j plus 4 plus 1, 2j plus 5, from j equals 1 to 6. Number 3. Rewrite the summation so that the index starts at m equals 0. If k equals 4, so k minus 4 equals 0. And we want the new index to start at m equals 0. So k minus 4 equals m, or k equals m plus 4. So when k equals 4, so m equals 4 minus 4 is 0. And when k equals 10, so m equals 10 minus 4 is 6, right? So the sum of k equals 4 to 10, k squared minus 3k becomes the sum of m equals 0 to 6 and k equals m plus 4. So we have m plus 4 whole squared minus 3 times m plus 4, right? So we have the sum of m equals 0 to 6, m plus 4 whole squared equals m squared plus 8m plus 16 minus 3m minus 12, right? So the final answer is the sum of m equals 0 to 6, m squared plus 8m minus 3m is 5m, and 16 minus 12 is 4. Number 4. Rewrite the sum of f of I plus 1 from I equals 0 to n minus 1 using an index that starts at k equals 1. We want the new index to start at 1. Since the expression contains I plus 1, a natural choice is k equals I plus 1. So I equals k minus 1. Now change the limits. When I equals 0, so k equals 0 plus 1 is 1. And when I equals n minus 1, so k equals n minus 1 plus 1 is n. Now replace I plus 1 by k. So the sum of I equals 0 to n minus 1 of f of I plus 1 becomes the sum of, when I equals 0, so k equals 1, to k equals n when I equals n minus 1. And I plus 1 becomes k, so we have f of k. This type of shifting is very common in sequence, series, and calculus. Number 5. Rewrite the following summation so that it starts at j equals 0. So when I equals 2, so I minus 2 equals 0, right? And we want j equals 0. So I minus 2 equals j, right? So let j equals I minus 2, so I equals j plus 2. And when I equals 2, so j equals 2 minus 2 is 0. And when I equals n plus 2, so j equals n plus 2 minus 2 is n. So the sum of I minus 1 whole squared from I equals 2 to n plus 2 becomes the sum of, when I equals 2, j is 0, and when I equals n plus 2, j equals n. And when I equals j plus 2, we have j plus 2 minus 1 whole squared, right? So the final answer becomes the sum of j equals 0 to n. J plus 2 minus 1 is j plus 1 whole squared, or the sum of j equals 0 to n, j squared plus 2j plus 1.